All right, so logarithms, 1 to 27. If we remember, rewrite each log in exponential form. We have log form where we have log, get some lead here. If we have log base b of m equals n, that's my log form. In exponential form, that would be b to the n equals m. So we have log form, and we have exponential form. All right? So, rewriting in exponential form. Log base 13 of 169 equals 2. In exponential form, my base is still 13. My exponent is 2. 169 would be the answer. And what I have written should be a true statement. 13 to the second power is 169. Yes, it is. Okay. What would this one look like? This one would be 11 to the what power? Equals, that's what it looks like in exponential form. All right, now let's go backwards. We have exponential form. We're going to write the word log. The base of the exponent, or the base of the power, is still the base of the log. And then my exponent and the number out here get flipped. So log base 625 of 25, say what I'm saying, or write what I'm saying, equals 1/2 is what that one would look like. And this one we would have log base A of 37 is equal to B. So those ones are pretty quick, just rewriting in the other form. Okay. All right, evaluate each expression without a calculator. Now I understand you're probably going to have a calculator with you on the test, right? But evaluating without a calculator means if I were to put equals x here, and then I were to think to myself, okay, in exponential form, this is 6 to the x is equal to 36. What does x have to be in order for this to be a true statement? X has to be 2, because 6 to the second power is what gets you 36. I'll show you in a minute how to get it with a calculator. Over here, I need to think 27 to the what power equals 1/3. Well, anytime I have a whole number and I have a fraction, I know that my answer, or my exponent, has to be a negative number. I know that 27 to the negative first is equal to 1/27. Yeah? How do I get a 27 to equal a 3, though? Take the cube root. Yes? So what's an exponent that represents a cube root? 1/3. So I could check that by saying, okay, it's 27 to the negative 1/3. Let me put it in parentheses. Negative 1/3. Does that equal 1/3? Sure looks like it to me. Yep. So that's my answer. Here's another one. 7 to the what power equals 1/343. Again, I have a whole number and a fraction, which tells me that my answer, or that exponent, has to be negative. So 7 to the negative first is 1/7. How do I get 1/343? What do I have to do to that 7? 7 squared. Nope. 7 to the third. Yep. So this is really 1/7 cubed. So the exponent here has to be a -3 in order to make that one true. Again, I'll show you another way to do it with the calculator. This one, 5 to the what power equals 1? Well, how do you get a 1 result when you have an exponent? The exponent has to be 0. Okay? All right. On your calculators, most of our calculators will not let us type in a base. We have to use something called the change of base formula. So I'm going to type in log of 5.2 and divide it by the log of 4. let's see, log 5.2 divided by log of 4. And I do get a decimal. Approximate to the nearest thousandth, which is, I believe, 3 digits past the decimal. So 1.1892 would be 89 is my answer there. Okay. Natural log of 64. Natural log, I can just use the natural log button on my calculator. Super simple. 4.1588 would round off to 159. Log of 37, a log with a plane with no base. What is a log with no base known as? 10. Base 10, it's a common log. That I can plug straight into my calculator. Log 37 is 1.568. And finally, log base 4 of negative 70. I would have to use change of base there again. So log of negative 70 divided by log 4. Let's see. Log of negative 70. Uh-oh, error. What does that mean? You can't take the log of a negative number. So this is kind of a trick question. As soon as there's a negative in there, we have an undefined answer. Okay. Any questions about those? I know I went through those kind of quickly, but hopefully we should be good. Ready for number 13? Expanding logs. I love expanding and condensing. All right. We have natural log. We have two things. One of which, or they are connected by multiplication. Expansion changes multiplication into what? Addition. So this is really the natural log of z to the 5th plus the natural log. Can I call this an exponent? Because we don't have log rules for radicals, but we do have log rules for exponents. X to the what? Cube root would be what as an exponent? 1/3. Square root would be 1/2. Fourth root would be 1/4. And the last thing I have to do for expanding is bump those exponents out to the front. So I have 5 natural log of z plus 1/3 natural log of x. Okay? All right. This guy, I'm going to start off by simplifying these parentheses by giving the exponent both to the top and the bottom. That gives me log base 2 of x squared over y to the what? 10th. Now I'm going to split up the fraction. The fraction is division. What does division expand to? Subtraction. That gives me log base 2 of the top minus log base 2 of the bottom. And the last step, take those exponents, bump them to the front. So 2 log base 2 of x minus 6 log base 2 of y. Okay? Any questions there? That's pretty much the same thing I have here, isn't it?
How'd you get 6?
I'm sorry, it's a 10. I don't know how I got a 6. Better? Yes. This is pretty much the exact same thing I just did, isn't it? Because after I distributed the exponent, it made it just like this problem. So I have log base 4 of the top minus log base 4 of the bottom. Bump those exponents in front. So I have 4 log base 4 of A minus 2 log base 4 of B. And number 16, I have a bunch of stuff connected by multiplication. So just like in that first one, multiplication breaks up to what? Addition. So log base 3 of A plus log base 3 of B plus log base 3 of C to the 6th And the last thing I do is bump any exponents forward. I only have one exponent. So the final answer should look like log base 3 of A plus log base 3 of B plus 6 log base 3 of C. And that's my expanded form. Been a while since we did these, isn't it? Okay. Now we're going to condense. We're going to do the opposite. So the last step here was bumping those exponents forward. That's the first step here. So I see an exponent, it's got to go back. See an exponent, go back. See an exponent, go back. So that gives me log base 6 of A to the 6th minus log base 6 of B to the 2nd minus log base 6 of C to the 2nd as well. Yes? And our rule for condensing, subtraction is going to condense to division, right? And pretty much our rule is anything that comes after a subtraction sign, goes on the bottom. What comes before the subtraction sign goes on the top. So that's going to give me log base 6. Where's the A to the 6th going to go? On the top because it's before the subtraction sign. After a subtraction sign is going to give me B squared on the bottom. Also after a subtraction sign gives me C squared on the bottom. Make sense? Okay. All right. One thing I notice here. All of these guys have the same exponent, don't they? And that exponent is a fraction, which means it's going to turn into what? A radical. So that tells me that all of these guys are under the same radical. And what is that radical? A cube root plus, I have a log base 8. I have the cube root, because 1/3 is a cube root. A, is it going to be times B? It's connected by plus, so yes, it's going to be times. And is it going to be times C? Yes, because it's connected by addition also. And I have one last addition, so I'm going to get log base 8 of D times the cube root of ABC. Kind of sort of makes sense? Again, these are all multiple choice. All right, starting with my exponents here. Natural log of x to the 5th minus natural log of z to the 5th minus natural log of y to the 30th. So just like up here, anything before the minus sign is on the top, anything after is on the bottom. So what goes on the top? Where does the x to the 5th go? Top. Z to the 5th? Bottom, because it's after a subtraction sign. Y to the 30th, also on the bottom, because it's after a subtraction sign. And that's my answer. Over here, I'm going to bump those exponents back. So I have log base 2 of u to the 2nd plus log base 2 of w to the 2nd minus log base 2 of v to the 12th. So I have a subtraction in there, so I am going to condense to a fraction. Does the u squared go on top or bottom? Top, because it's before any negative signs. What about the w squared? Where's that going to go? It's after a plus sign, so it's also on top. V to the 12th is after a minus sign, so it's going to go on the bottom. Okay, and that's the end of my expanding and condensing. Now we get into the fun part of logs, which is graphing. All right, identify the asymptote, domain, and range of each. So I'm going to start off with identifying what is h in this case. H and k. What is h here? -3. What is k? K is 3. My asymptote is x equals h, or in this case, x equals -3. I need to draw in that asymptote. It is a vertical asymptote at -3. Okay? My xy chart, k goes in the middle of my xy chart. However, with logarithms, everything's backwards of what we think. So that k value actually goes in the middle of the y side. And what do I do from there? Count up and count down. Okay. Now, what am I plugging into? Am I plugging into this whole thing? I have to do some rearranging, don't I? So let's see. I wish I had some more space here. I'm going to need to subtract 3, so that's going to give me y minus 3 equals log base 1/3 of x plus 3, because I got to get x by itself. So what am I going to do next? Go to exponent form. It's easiest to go to exponent form if your log is on the left. So log base 1/3 of x plus 3 equals y minus 3. So I have 1/3 as my base. My exponent is y minus 3 equals x plus 3. Subtract your 3. So x equals 1/3 to the y minus 3 minus 3. That's my equation that I'm plugging these guys into. Again, changing it to exponent form and just getting x by itself. So, let me start plugging some stuff in. 1/3 to the parentheses, y minus 3. I'm going to start off with y is 1 minus 3. Close your parentheses so it knows that minus 3 is happening after, and I get 6. Now I'm going to go change the 1 to a 2. And I get 0. I'm going to change the 2 to a 3. And I get -2. Change the 3 to a 4. -2 point, we'll call it 2.7. And finally, to the 5, we'll call that -2.9. And as I graph those, I have to be careful because my x values are the ones that are funky. So 6, 1, 0, 2, -2, 3, -2.74, and -2.9, 5. So my graph goes like this. Which one is all real numbers, my domain or my range? The range is all real numbers. Up and down, it doesn't matter how far you go. What's my domain? X has to be what? Greater than -3, and it cannot be greater than or equal to because it's never going to be on that asymptote. Okay? Questions? It's been a long time since we've done this. All right, number 22, what is my h value? 1. My k value? 0. So my asymptote is x equals 1. That would be my vertical line right there. Okay. So, I go to my XY chart, And 0, my k value goes in the middle of my y's. -1, -2, 1 and 2 to find my values around there. And now I have to do some rearranging here, right? So let's see. If I have y equals log base 3 of x minus 1, and I need to get x by itself, I need to go to exponential form. It's going to be easiest to do that if I bump the y to the other side. Then I have 3 to the y power equals x minus 1 when I change it to exponential form. Add 1, 3 to the y plus 1 equals x. That's the equation I'm plugging these numbers into. So 3 to the parentheses, -2 is what I'm starting off with, plus 1, I get 1.1. I'm going to go change the -2 to a -1. 1.3. Change the -1 to a 0. I get 2. Change it to a 1. I get 4. And change it to a 2. I get 10. So now I can plot my points. 1.1, -2. 1.3, -1. 2, 0. 4, 1. And 10 is off my graph, so I just need to aim that direction. And my graph looks something like that. What's my domain here? X is greater than 1. My range, all real numbers. Okay. Any questions there?
Why did you start with 1 in the middle? Why did you start with 1 in the middle? You put h in the middle, right?
K goes in the middle. With logarithms, it's always k that goes in the middle, and it goes on your y side in the middle. Okay? H is what gets you your asymptote. All right. The last part of this log section I am going to do on a separate piece of paper, so I actually have room to do it. I need to solve the equations round to the nearest 10,000th. One thing about log equations, we also always need to check for extraneous solutions, so I'm also going to be doing that. Okay? So, let's see, number 23 says log of 5 plus log of x equals 1. When we're solving, our general rule is condense first. Hang on, can't spell. Condense, and then go to exponential form. So condense and then change form. The only time you don't follow that process is if you have log equals log. And we'll see one like that. So I'm going to condense this first. This is connected by addition, which means it's going to condense to what? Multiplication. 5 times x is 5x. So now I can go to exponential form. I've condensed it, so now I'm going to change the form. What's the base here? 10 to the what power? 1 equals 5x. Or in other words, 10 equals 5x. If I divide by 5, what does x equal? 2. I do need to check my answer in the sense that I'm looking for, remember the issue I had where I had the log of a negative number? I can't have the log of a negative number. If I plug in 2, it doesn't change this at all. That one's good. Log 2 is positive, so my answer is good. Easy peasy. 24. Log 2 plus log x squared minus 2 equals log 4. So this one has 3 logs. I'm still going to condense first. I'm going to condense what's on the same side. If I condense these, they're connected by addition, so what are they going to condense to? Multiplication. So that gives me 2 times x squared minus 2 equals log 4. Now that I have it condensed, do you see how I have log equals log? When I have log equals log, I can just drop the logs. So I have 2 times x squared minus 2 equals 4. And that's all I'm solving. So I distribute 2x squared minus 4. When I add 4, I get 2x squared equals 8. X squared equals 4. So what does x equal? Positive and negative 2. Now I need to see if they're both going to work. So let's try positive 2. If I plug in positive 2, doesn't change this one. Positive 2 squared is 4 minus 2. That remains positive. And that one's positive. So positive 2 is good. What about negative 2? Negative 2 isn't going to change this one. Negative 2 squared is positive 4. Minus 2 still makes this positive. And 4 isn't going to change if I plug in negative 2. So both of them check out as good answers. Okay. So. Let's see. 25. Log base 5 of x minus log base 5 of x minus 6 equals 2. Again, I'm going to start off with condensing. That's connected by subtraction, so what's it going to condense to? Division. So that's what division looks like. Now if I go to exponential form, what does this become? 5 to the second is equal to x over x minus 6. What is 5 to the second? 25 equals x over x minus 6. I'm going to call that 25 over 1, and all I'm going to do is cross multiply. 1 times x is x, and then on the other side I have 25 times x minus 6. So x equals 25x minus what? 25 times 6 is 150. You following? Move down to the next page so I don't run out of room. Let's see, I need to get my x's together. So I'm going to subtract 25x. And that's going to give me negative 24x equals negative 150. Divide by negative 24. And what does that give me? X equals negative 150 divided by negative 24, 6.25. Now my answer key actually has that as a fraction. So if I needed to leave it as a fraction, I can just use my fraction decimal button, change it to an improper fraction, 25/4. So either way, you'll just have to look at the answer options to see what you've got going on there. Okay. Let's see. So 25/4 or 6.25. Would 6.25 make this a negative? No. Would it make this a negative? 6.25 minus 6 still remains positive, doesn't it? So as long as it all remains positive, my answer is valid. Okay. Let's see. I'm going to try something with this. Okay, 26 says log base 16 of 4x plus 5 equals log base 16 of x plus 2. What do you notice here? Log equals log. Yes? When it's log equals log, drop the logs. You have 4x plus 5 equals x plus 2. I need to get my x's together, so I'm going to move them to the left. That gives me 3x plus 5 equals 2. Move 5. 3x equals negative 3. So what does x equal? Negative 1. Yeah? So I just need to check this to make sure that it keeps everything positive up here. 4 times negative 1 is negative 4. Plus 5 is positive 1. It ends up being positive up here. That's good. Negative 1 plus 2 also ends up becoming positive, so my answer checks out in both places. Okay? And the last log problem. Woohoo! Says log base 5 of b squared minus 16 equals log base 5 of 3b plus 2. This one also is log equals log, correct? So I can just cross out my logs. So b squared minus 16 equals 3b plus 2. What do I do when I have a b squared that I can't get by itself? I have to move everything to the same side and snowflake or factor. So I'm going to subtract 3b. That gives me b squared minus 3b minus 16 equals 2. Move the 2. So everything's over there. B squared minus 3b minus 18 equals 0. I can snowflake this guy. Negative 18 and negative 3. What are two numbers that multiply to get negative 18 and add to get negative 3? Negative 6 and 3. So I have b minus 6 and b plus 3. What do I get for an answer here? B equals 6. And here, b equals negative 3. So I have to check out both answers. 6 squared minus 16, is that positive? 6 squared is 36, minus 16 is a positive number, isn't it? It's 20. And 3 times 6 is 18, plus 2 is 20. This is positive in both spots. Negative 3 squared is what? 9. Minus 16 is negative. That one drops out. That's my extraneous solution there. Okay? All right, so there's your logs. Happy studying.